I would like to explain you which point, as architect, which points you need to take into account during the design of your building to make it fully compliant with Turkish fire code and also the international codes. Even if the mechanical design is executed and is followed by the mechanical designer, as architect, you need to check whether their requirements or whether their design criteria are going parallel to your architectural design. Otherwise, the coordination between the architectural, structural design and the MEP. MEP design means mechanical and electrical and plumbing. They are calling it MEP on site. The MEP design, the coordination between MEP and architectural becomes more difficult to you if you understand, if you emphasize the inconvenient requirements of the MEP designer at the end of the project. That's why when we start the project, first of all, we are trying to review and check the shaft locations, main mechanical and electrical room locations, and also the location of the combined water-based suppression system riser, etc. And it gives us it makes our design very easy to be executed because it's already solved, it's already placed, all the shafts, main electrical rooms, and then we can use the rest of the area as we require for our architectural point of view. That's why the things that I will explain you from now on, it's very important for architects to understand and to solve before beginning before start to develop the design in your projects. First of all, if you have a sprinkler system, if you have a water-based suppression system in your building, the fire pump room is the heart of this precaution. We need to design and we need to locate this very, we need to give attention to the location of this room because it's the heart of the system. If the pump does not work, or if we have some problem to reach the fire pump room, the rest of the system will not work, and all of the design will go to rubbish because of our faults. The fire pump room shall be 2-hour fire rated separate zone. First of all, that's why we need to design their perimeter walls accordingly. They should be at least 20 centimeter block walls to fulfill this fire rating requirement. And also the most important thing, the fire pump room shall be just next to the fire tanks. If we have separate fire water tanks, reservoir and fire pump room, it's really difficult to get this water on the fire pump room. Some of the architects are requiring this due to the lack of area within the building, but it's not a correct design. We always keep the water tanks just next to the fire pump room so that we have these pumps in connection with the water, and we can keep the system convenient all the time. And the third one, but I think is the most important one, the fire pump room shall have direct access to a staircase. Most of the architects are not understanding the main reason of this requirement, but the fire pump room shall be kept accessible in case of fire in the building. It means even if we have a huge fire, even if we have a large fire incident within the building, we need to reach the fire pump room to check whether they are working as required, or maybe we need to start manually these fire pumps. That's why even if the building is burning, I'm exaggerating, even if the half of the building is burning, we need to access this fire pump room. And the only way to access these fire pump rooms by not affecting the fire incident within the building is to have a direct connection between the fire pump room and the staircase. That's why we are always checking at the beginning of the project whether we have a direct connection to the staircase without passing other areas such as car parks or any other office area or residential area. This is also important. At the first stage of the project, you need to decide the location of the water tanks, and just next to the water tanks, there should be a fire pump room, which is directly connecting to the staircase. And then you give this location to the MEP designer, mechanical designer, and they check whether the fire pump room area is adequate to put the fire pumps in. And also they will check the capacity of the water tanks. If they are not happy with them, they can inform you and it can be revised. But the first thing is the location is decided by the architect and then given to the mechanical designer. And also this is also very important design criteria for the architects regarding the mechanical requirements. As per Turkish fire codes, we need to have separate vertical pressure zones for the water-based suppression system because we have some limitations, both minimum and maximum limitations for the system pressure limitations. For example, at the highest point, we need to have at least 4 bar of water pressure. And also at the lower point of this vertical pressure zone, the maximum pressure is limited to 12 bars. That's why for each 45 meters, we need to have a separate vertical pressure zone. It is also the same for the daily usage system. For example, heating and cooling system, we also have some vertical pressure zoning. But today I am just explaining you the from fire point of view. That's why if you have more than 3 vertical pressure zones, it means your building is higher than 135 meters. You need to provide an additional intermediate technical floor on your building. For example, this is a project from Uzbekistan. The building is more than 200 meters. That's why after having 3 vertical pressure zones, we provided an intermediate level of pump, and the upper levels are feeding by this intermediate level of fire pump. If you are not taking this detail during your design, take into account during your design, the mechanical designer comes into the project. They will ask you to allocate an intermediate floor, for example, 20th floor or 21st floor for the mechanical systems, and it will cause you some problem because you are always thinking that this level also will be used as a social area or will be used as residential or what is this, as a business unit. And then you will lose a whole floor by the requirements of the mechanical designer. But if you have some knowledge about the vertical pressure zoning, and if you have knowledge what is the limitation for having an intermediate level of mechanical floor, you will take this into account from the beginning of the project, and you will develop your design accordingly, and you are not facing any problem during your design phase. It means when you exceeding 135 meters in your building, you need to think that you need to take into account that you will have an intermediate level of mechanical floor, and one of the floor, according to the area of your sectional area of your building, will be allocated for the mechanical system. And also structural engineer should take this into account because in this floor you will have water tanks as well. Having a water tank on the upper floors is really difficult from a structural design. The structural design and the beams and the columns of this floor shall be designed accordingly to have an adequate load-bearing feature. Otherwise, you will you may not able to provide, you may not able to locate these water tanks on this floor. That's why all of these together should be coordinated by the architects from the beginning of the project.